Welcome everybody to Integrated Math 3. In today's episode, we're going to be discussing Chapter 2.1.2, which is Modeling with Parabolas. So this will be the second time we've encountered the whole idea of modeling in mathematics. And what they mean by modeling is coming up with an equation that represents the situation, right? A mathematical equation that represents the situation at hand. And so what we've got in this 2-13 problem is a situation of jumping jackrabbits. And it says the diagram at the right shows a jackrabbit jumping over a 3-foot high fence. To just clear the fence, the rabbit must start its jump at a point 4 feet from the fence. And we have to sketch a situation and write an equation that models the path of the jackrabbit. And we have to show or explain how we know the sketch and equation fit the situation. So let's take a look at how this works here. I'm going to go and just draw this as a mathematical model instead of rabbits, because this diagram up here can get a little confusing. And I'm going to go and just draw this on a coordinate plane right here. So assuming the rabbit begins right here, he's going to go up and then he's going to come down. Now, what we notice here about this model as we translate this picture into this graphical image here is that he travels a distance of 8 feet. Now, there's a couple of ways you can interpret this. You actually could have centered the parabola at the origin. I'm choosing not to. I choose rather to start his distance from 0 and know that by the time he's done, he travels a length of 8 feet. And so now from here, we know that he hits a value of 3 feet here, and it's going to be right at the dead center of that parabola. So what I have to do is I now have to know what the distance, or the midpoint is, between 0 and 8. Well, obviously, that's 4. And so what that gives me is it gives me a value of 4, 3 for my vertex. I'll go and clean that up a little bit, actually. 4, 3 as my vertex, right? And I know that because his apex happened halfway between his jump, as dictated by the drawing in here. And because of the fact that we're using a parabola to model this, the vertex would be in the dead center of the x-intercepts. 3, because he's 3 feet high. We see that based on this picture right here. So from here, how can we use this mathematical model to write the equation of the parabola? Well, luckily, in class, in the previous lesson, we learned about vertex form. And in this case, it's going to be y equals some type of x minus 4 squared plus 3. Now, ordinarily, this would be enough. However, if I leave the parabola just like this, it's going to graph like that, which is upside down compared to what we actually want, because the gravity is going to pull the rabbit back down to earth. So what I'm going to do is I'm going to actually create a new variable here. And the variable here is going to be the letter A. And that's the thing that I'm going to solve for. And the A, in case we don't remember from the parabolas lesson, the A is the stretch factor for the parabola. It tells us if the parabola is being stretched vertically, compressed vertically. And if A is negative, it tells us whether or not the parabola is upside down or right side up. And so based on solving for this A, once I solve for it, I'll be able to figure out the final equation of this parabola. So how do I solve for A? Well, what I'm going to do is I'm going to go ahead and pick 2 points that are not my vertex, because I've already used my vertex here in the 4 and the 3 here for the H and K. So I'm going to go ahead and pick another coordinate that I know is going to be on this parabola. The easiest one to pick is this dude here, 0, 0. And this is why I opted not to center the parabola at the origin. Because if I did, I would have to choose something behind 0 or in front of 0. And so from here, I'm going to go and say, all right, this is the point 0, 0, which then gives me a 0 for y, a, and then a 0 for x, and then plus 3. So what I get here is if I go ahead and subtract 3 from both sides, I'll get negative 3 equals a times 16, because 0 minus 4 is negative 4. Negative 4 squared is positive 16. If I divide both sides by 16, I'm going to get a equals negative 3 over 16. And then that's going to get me a final equation of y equals negative 3 over 16, parentheses, x minus 4 squared plus 3. And that is my final equation for this particular situation. Now, if you're wondering, wait a second, a is negative, it should make sense, right? A being negative makes a lot of sense because the rabbit's jump is in the trajectory of a parabola, which goes up and then comes down. So hopefully that model makes enough sense. Give me a second. I'll be right back with the next situation. We'll model once again with a parabola. I'll be right back. In this next problem, they talk about Mrs. Beebe kicking the soccer ball. It travels a horizontal distance of 150 feet and reached a height of 100 feet at its highest point. We're going to sketch a path. This is basically the same thing as the jackrabbits, right? Except we're going to replace jackrabbit with soccer ball. So again, I'll go and just draw my diagram here. This is 0, 0, 0, 0. And then, of course, the ball is going to follow that path just like that. Whoops, ran out of space there. My little tablet cut out there. From here, it has a horizontal distance of 150 feet, and it reached a highest point of 100 feet. So I know that this is something, comma, 100. Now again, what is that something? Well, I'm assuming it's 75, right? And 75 because the apex of the parabola is going to be where the highest point of this thing is going to be. So we just sketched this thing, that's A. And now what we have to do is we have to find out how far horizontally is the ball from Mrs. Beebe when it is 25 feet high. Well, what they're telling you here without really saying anything is they're asking you to write the equation, because there's no way we're going to be able to visually pick a point on here and guess. So let's find out what the equation for this thing is here. So I'm going to go y equals, don't forget the a, because everyone forgets the a. It's going to be x minus 75 squared plus 100. And now I'm going to go ahead and find a value for a by using this point here, 0, 0. And so now that's going to be 0 equals a parentheses negative 75 squared plus 100. So we're going to get into the venture of some large numbers here. So I'm going to go and find out a calculator real quick. That way I can get 75 squared. I'll be right back. Actually, what am I saying? I don't think I need a calculator. I can say this is negative 100 equals a times negative 75 squared. Now, what I'm going to do here, a way to circumvent the calculator and mitigate our need for it, is I'm going to go and divide both sides by literally negative 75 squared. Again, that's a number. I just don't really know what it is right now. And the way I'm going to look at this is I'm going to say a equals negative 100 divided by 75 times 75. And so now what I can do with this is now ultimately it's going to end up being a negative number. And if you're wondering why I didn't include the negatives here, it's because a negative times a negative is a positive, right? So it doesn't really matter if the negatives are there or not. These guys both divide into 25. So that's going to become a negative 4. That's going to become a 3. And what I get is negative 4 over 3 times 75. So that's going to be 75 times 3. So that's going to be 15, 20, so 225. So 225 equals A. So that's my A value. So you see, we did that with no calculator. So that means that my equation for this thing, I'm going to move to the right here a little bit, slightly to the right. I'm going to say, okay, my equation ultimately is going to be y equals negative 4 over 225, right? 225, negative 4 over 225, parentheses, x minus 75 squared plus 100. And that's my equation so far. And so now what they want to know is they want to know how far horizontally is the ball when is the ball from Mrs. Beebe when it is 25 feet high. So careful, I'm trying to find out the horizontal distance, which means I'm solving for x in this case. They are telling me that the ball is 25 feet high. So let's go ahead and plug in a 25 into the y for height. So negative 4 over 225, parentheses, x minus 75 squared plus 100. So I'm going to go and subtract 100 from either side. So that's going to be negative 75 is equal to negative 4 over 225, parentheses, x minus 75 squared. So now I'm going to go and multiply both sides by 225 over negative 4. So again, this is multiplying by 225 over negative 4. The negatives are going to cancel each other out. So what I have is 225 times 75. That's a big number, so go ahead and bust out a calculator for that. That's going to be 16,875 divided by 4. And if I divide that by 4, I end up with 4,218.75. And that's going to be equal to x minus 75 squared. Okay, at this point, we are going to square root both sides. And we're going to get x minus 75 is equal to whatever the square root of 4218.75 is. So 4218.75, we're going to square root that. Again, I'm just doing this on the calculator. What I get is I get plus or minus 64.951 as my decimal. And so now what I'm going to do is I'm going to add 75 to either side. Now I'm going to end up with two answers here. What I end up with is 75 plus 64.951 or 75 plus negative 64.951. And I end up with, let's see here, if I add that to 75, I end up with 139.951. Okay? And then if I do the opposite, if I do 75 minus the 64.951, again, I'm just doing this on the calculator at this point, I get 10.049. So there are two times when the ball is that high up in the air. One time when you're close to Mrs. Beebe, and the second time is when you're further away from Mrs. Beebe. So hopefully that makes sense. All I did was I just plugged in at 25. I did have to resort to using a calculator at the end to take some square roots of some pretty ugly numbers, but it all ended up working out. So I'll be back with the next example. All right, and here we are with the last problem at the skate park. The hot new attraction U-dip is a cement structure embedded into the ground. The cross-sectional view of the U-dip is a parabola that dips 15 feet below zero, not below zero, but below the ground. The width at ground level at its widest part is 40 feet across. We got a sketch and all that stuff. So basically, it's the same as the other ones, except this time, it looks like we're going to be going below the ground. So if I had really had to graph this thing as a mathematical model and take it really literally, it probably does something like this right here. And again, since it's 40 feet across, that's going to be a 40 right there. And again, I'm hoping people kind of get used to this idea that this is 20, and this would be 20 comma negative 15. And again, how do I know that it's negative? Because this guy dips 15 feet below the ground, right? So we're underground, which means we're at negative spacing. All right, so we're going to find an equation of a parabola that models this idea. So again, how do we work this out? Y equals a, parentheses, x minus 20 squared minus 15. Again, vertex form of a parabola, right? So again, use 0, 0. And again, I can't emphasize this enough. That's why I center my parabola not at the origin. I actually begin at 0, 0. It makes the solving for a part so much easier. So 0 minus 20 squared minus, not 75, but rather 15. And so now from here, I'm going to add the 15 to both sides. So I got 15 equals a times 20, negative 20 squared is 400. So a equals 15 over 400, which does in fact reduce if I divide. So that's going to end up becoming 3 over 80 if I divide both top and bottom by 5, and therefore reducing the fraction. So here we go. Here's the equation of the parabola. So I got y equals 3 over 80, parentheses, x minus 20 squared, squared, minus 15. And there you go. There was nothing else to do with this parabola except find the equation that models it. And so that is how we model using parabolas. I hope this all made sense. As always, please leave comments or questions in the comments area. I will see you all in the next episode.